This is a very short video describing normal distribution introduced by Carl Friedrich Gauss. Hence, normal distribution is also known as Gaussian distribution. It is one of the most popular distributions used to model data generated by a continuous variable. Any symmetric data having a bell-shaped histogram measured on a continuous scale can be modeled using normal distribution. Normal distribution is observed in many real-world phenomena in physics, engineering, social science, and business. There are two parameters for the distribution. The first parameter is mean, mu, and the second parameter is the standard deviation, sigma. Hence, the distribution is usually denoted by n mu sigma. Next, let us come to the properties of the distribution. The first property itself, mean equal to, median equal to, mode equal to mu. You know the reason behind it. Normal distribution is a symmetric distribution. For all symmetric distributions, mean will be equal to, median will be equal to mode. The second property is variance equal to sigma squared. Next, the third one is normal probability function is given by 1 divided by square root of 2 pi sigma e raised to minus x minus mu the whole square divided by 2 sigma squared. Using this function, we can calculate normal probabilities. Also, this normal probability curve will be a bell-shaped curve as shown in this figure. And the data distribution will be as follows. 68.27% of the data lie between mu minus sigma and mu plus sigma. 95.45% of data lie between mu minus 2 sigma and mu plus 2 sigma. 99.37% of data will lie between mu minus 3 sigma and mu plus 3 sigma. Next, we are coming to standard normal distribution. Any normal distribution with mean 0 and standard deviation 1 is known as standard normal distribution and is denoted by n01. The peculiarity of standard normal distribution is nothing but any normal distribution can be transformed to standard normal distribution if you take the following transformation. You assume X follows normal distribution with parameters mu and sigma. This symbol is used for follows. Now, if you take the transformation Z equal to this x minus mu by sigma, that follows standard normal distribution or a normal distribution with mean 0 and standard deviation 1. Next, we can calculate normal probability using the following Excel function. Note that you cannot calculate probability mass function in the case of normal distribution because normal distribution is the distribution of a continuous variable. For the continuous variable, you cannot calculate probability mass function or probability of a point. So you can calculate only normal cumulative probability. Normal cumulative probability means probability x less than or equal to x. That will be same as probability x less than x. The reason is nothing but for a point there is no probability. That can be calculated using the Excel function norm.dist x mu sigma and 1. This is the logical value. So what happens is we are calculating the area below the normal curve. Next, we have the usual remarks. If you want to calculate probability x greater than x, it can be calculated as 1 minus probability x less than x. Please note that here I am not using less than or equal to, I am using only less than x because in this case less than x and less than or equal to x are the same thing. Second one, probability a less than or equal to x less than or equal to b, which is same as probability A less than X, which is less than B, equal to probability X less than B minus probability X less than A. That means probability from A to B can be calculated as probability up to B minus probability up to A. For this, you can use Excel functions discussed previously. Finally, the inverse function is given by norm.inv p comma mu comma sigma. The utility of this inverse function I will be illustrating using an example. Next, we will take an example for normal distribution. According to a survey on use of smartphones in India, the smartphone users spent 68 minutes in a day on average in sending messages, and the corresponding standard deviation is 12 minutes. Assume that time spent in sending messages follows normal distribution. We are asked to solve the following questions. What proportion of smartphone users are spending more than 90 minutes in sending messages daily? Second one, what proportion of customers are spending less than 20 minutes? Third one, what proportion of customers are spending between 50 minutes and 100 minutes? So in all the three questions, you are asked to calculate proportion. Proportion is same as probability. So proportion of what? Time spending in sending messages. It is given that time spent in sending messages follows a normal distribution with the mean 68 minutes and standard deviation 12 minutes. Hence, we can use normal distribution with the mean 68 and standard deviation 12. Next, let us come to the first question. You are asked to calculate probability that smartphone users are spending more than 90 minutes in sending messages daily. That means probability X greater than 90. Probability X greater than 90 cannot be calculated directly. So we have to take it as 1 minus probability X less than 90. X less than 90 can be calculated using the Excel function. So I can use the function as 1 minus the Excel function norm.dist. First argument will be 90, then the mean 68, then the standard deviation 12, finally the logical value 1. Using that function in Excel, we will get the final answer as equal to 0.0334. In the second question, we are asked to calculate proportion of customers spending less than 20 minutes. Proportion means probability. That means probability of the customers spending less than 20 minutes. This is probability X less than 20. Probability X less than 20 can be directly calculated using the Excel function norm.dist. Value is 20, mean is 68, standard deviation 12, and logical value is 1. Using that one, you will get the value as equal to 0.000032. Finally, you have to calculate probability of customers who are spending between 50 minutes and 100 minutes. That means probability 50 less than X less than 100, which can be calculated as probability X less than 100 minus probability X less than 50. That means probability from 50 to 100 is nothing but probability up to 100 minus probability up to 50, which can be calculated using the Excel function, and the answer will be so and so. Next, we are coming to the second example. The fill amount of 2 liter soft drink bottles is normally distributed with a mean of 2 liters and standard deviation of 0.05 liter. If the bottle contains less than 95% of the listed net content, that is 1.9 liters in this case, the manufacturer may be subject to penalty by the State Office of the Consumer Affairs. Bottles that have net content above 2.1 liters may cause excess spillage upon opening. What proportion of the bottles will contain? Question number 1, between 1.9 and 2 liters. Question number 2, below 1.9 or above 2.1. Question number 3, at least how much soft drink is contained in 99% of the bottles? Here, it is clearly specified that the fill amount is normally distributed with a mean 2 liters and standard deviation 0.05 liters. So we can use a normal distribution with a mean 2 and standard deviation 0.05. Your first question is the probability between 1.9 and 2 liters, which can be calculated as probability x less than 2 minus probability x less than 1.9. You can use the Excel function. Using the Excel function, you will get the answer as equal to 0.4772. Second one is below 1.90 liters or above 2.1 liters. That means probability x less than 1.9 plus probability x greater than 2.1. Probability x greater than 2.1 can be calculated as 1 minus probability x less than 2.1. You can use your Excel function. Using that Excel function, you will get the final answer as equal to 0.5228. Third question is little complicated. At least how much of soft drink is contained in 99% of the bottle? At least how much of soft drink is contained in 99% of the bottles? We will assume at least K liters is contained in 99% of the bottles. This means probability X greater than K equal to 0.99. Probability X greater than K is 0.99. Probability x greater than k we cannot calculate, but we can calculate probability x less than k. If probability x greater than k is 0.99, probability x less than k will be 0.01. So we have to find out the value of k in such a manner that probability x less than k equal to 0.01. For that, we can use the inverse function. Norm.inv 0.01 probability is 0.01, comma mean 2, comma standard deviation 0.05. If you open an Excel file and enter this function, you will get the answer as equal to 1.8837. Normal distribution is one of the most important distributions used in statistical analysis. With this, I am concluding at the discussion on normal distribution. Thank you very much. Next, we have to discuss sampling distributions. The knowledge of sampling distributions is really important for statistical inference. Thank you. Thank you very much.